I don't think I could pull it off and not have strands.
Imagine this with the right in the back. Oh my God.
I've made it.
Maddie, and you know, what's Maddie? And her old boyfriend. He has like.
Well, I've had days I've made it to almost third, fourth period, and just happen to go to the bathroom and just look in the mirror, and it's just like 3 or 4 hairs are just straight up. I was like, okay. I used to be able to really see that more when we had the projectors. Because when I would stand in front of the projector, it would go through my head or kind of hair, and I could see if I had just a cowlick. But when I was younger? Yeah. We can look at that after this year. We ready for this challenging section? We're going to add and subtract matrices to start with. To add or subtract two matrices with the same dimensions, add or subtract the corresponding elements. The sum or difference of two matrices with different dimensions is undefined or not possible. Okay, we ready for this? So these two matrices are both 2 by 2, yes? 2 rows, 2 columns. So the first thing we're going to do is take the 2 from the first one and add it to the 1 of the second because they're corresponding. Next, we're going to take the -1 and add it to 2. Then we're going to take the 3 and add it to 4. And then we'll take 0 and add it to -2. So what is 2 plus 1? 3. -1 plus 2. 3 plus 4. 0 plus -2.
Wait, are you getting a new note sheet?
Yeah. There you go.
Thank you.
Questions? That's it. Questions on this here? We ready for the next one? So the first one's a 3 by 2. The second one's a 3 by 2. So can we subtract these? Yeah. So we would do what? 2 minus -1. -3 minus 2. 5 minus 7. 4 minus 8. -2 minus -5. And lastly, 8 minus 2 minus -1 is 3. -3 minus 2. -5. 5 minus 7. -2. 4 minus 8. -4. -2 minus -5. And lastly, 8 minus 6. Questions on this here? So we feel comfortable with these here? All right, let's go on and do the next one. All right, so let's look at this here. So we'd have -8 plus 6, 1 plus -1, 5 plus 2, -4 plus 7. Yes?
I don't know if it's plus. Oh.
Plus in the middle. And then what? 3 plus 9?
Wait. So, -8 plus 6. 1
What did we say we had to do for two matrices to be right? So, exactly. Not possible. Because that's not even 3 and 9. That doesn't even make sense. Yeah, no, I just threw something up there. Yeah, because we need the dimensions to be the same because there's nothing that we can add the 3 to or the 9 to there. Because even if we did add zeros there, we're adding elements to the matrix. It's not a 2 by 2 anymore. It's now a 2 by 3. We changed it. We can't just change it to make it work. Questions on this here? And to answer your question, yes, we can do these in the calculator. So this one here, if I wanted to do it in the calculator, just like we did the other day, we need to plug the matrix into the calculator. So I can go second matrix, edit A, which is a 2 by 2, and incidentally, I already have it typed in. 5, 3. Once we get it typed in, we'll do second quit. Second matrix. Well, this time we don't just have 1, we have 2. So I'm going to go back over to edit, go down to matrix B, 2 by 2, type the second one in. 6, -4, -8, 2. Second quit. Okay. Now, I'm going to come back to the calculator here in a minute. But we said that this is matrix A, yes? And this other one is B, and we want to do what? Add them together. So in the calculator, the first thing I need to do is recall matrix A, yes? So we can go second matrix, enter. Because that first row of matrices is just recalling them, letting us use them to do different operations with it. Plus. Second matrix B. So we have A plus B, yes? Enter. 5, 3, -3, 5. And if we look at these two matrices, well, -1 plus 6 is indeed 5. 7 minus 4 is 5 plus -8 is, and 3 plus 2 is. It'll do it for us. So, what do we think? Addition, subtraction. Is it faster to do it by hand or in the calculator? Calculator. I think it's here nor there. But for some of these, it's easier to do them by hand. Some of them, it might be easier to do them in the calculator, yes? Because this one here, 2 minus -3 is 5. 5 minus 0 is 5. So we could rewrite it back out and say 2 minus -3, 5 minus 0, and get here. Or we can do the subtraction. So some of these, it's going to be easier to do them by hand. Some of them, it's going to be easier to do in the calculator. But it's not wrong to do them in the calculator. Questions on this here? Are you ready to see another example of addition or subtraction? Or do we need to see another example? I think you got this one, yes? So what is it?
It's just 3 minus 4.
Anybody want to help him?
That's what you did. Oh, okay. 3 plus 4, that'll be 7. What?
What is the dimensions of the first?
I have 3 of the bracket. Oh. I'm sorry.
Because again, they have to be the same dimensions. They have to look the exact same. Otherwise, we can't add or subtract. Now, we could technically multiply these two, but we're not doing multiplication today. Not possible. They've got to look the exact same. So these here, both of these we can do because they are the exact same dimensions. First ones are both 2 by 2s. The second ones are both 2 by 3s. Questions on these here? Scalar multiplication. Ready for this? When working with matrices, a real number is often called a scalar. Y'all have heard of scalars before because we can scale something up or we can scale it down. We can make it bigger or smaller. To multiply a matrix by a scalar, multiply each element in the matrix by the scalar. This process is called scalar multiplication. So here, what are we multiplying by? 2. So we do 2 times 2 times 2 times 1. 2 times 2 times 2. And then 2 times 2 times 3 is 2 times negative 2. Negative 4. 2 times 1. 2 times 5. 2 times 2. 2 times 0. You don't necessarily need the middle step, especially with these here where we're doing one operation. I'm writing out every step so that we can see it and it's helpful. Because there are some that do find having that middle step helpful for keeping track of all the information. Questions on any of this here? Well, we can do scalar multiplication and addition and subtraction together. We would do the scalar multiplication first. Now, if there's a number, especially with subtraction, bless you. So if this had been negative minus 3 times that matrix, we can multiply the second matrix by negative 3 in each element. But the sign, since we took the negative with it, would change back to plus because we applied the negative to the function. Does that make sense? Because if I multiply all of this by negative 3, the negative is now inside. We took it with it, so the sign between them is now plus. Does that make sense? Because we already applied the negative to it. We can't leave it as a negative. So you guys can watch this. So we said negative 3 also. Yes.
This side, negative 3, is it applied to both?
Nope, just the one. So we can say instead of negative 3, let's say 4. I'm just multiplying. I'm changing that to negative 4 because we can distribute this negative 3. What is negative 3 times 5? Negative 3 times 0. Negative 3 times negative 2. Negative 3 times 4. Now we need to distribute this 4 or negative 4 through it. We can choose one or the other. If we choose to multiply it by negative, or just the 4 first, 4 times negative 1 is 4 times 7. 4 times 3, 4 times 2. I didn't take the negative with it, so we are subtracting. Do y'all see that?
Yeah.
Now, if I instead had multiplied it by negative 4, now, okay, get the eraser back. Because negative 4 times negative 1 would be positive 4, yes? Negative 4 times positive 7 would make it, and make the rest negative, yes? Did we take the negative with it? Yeah, we took it and applied it, so that what we have left is going to be plus. We're going to add them. It will, because I'll rewrite it out here. Negative 15, 0, 6, negative 12. Plus, because what we originally had was, not plus, yes, minus. What we had originally was negative 4 8, 12, 8. Because if I subtract them, negative 15 minus negative 4, 0 minus 28, 6 minus 12, negative 12 minus 8. Well, the negative here make a, so it's going to be negative 11. 0 minus 28 is negative 28. 6 minus 12 is negative 6, and we get negative 20, yes? Let's look back over here. Negative 15 plus 4. 0 plus negative 28. 6 plus negative 12. Negative 12 plus negative 8. We get the same answer. But the key, what I'm wanting to point out, is that if we take and multiply everything by the negative 4, which we can do, we just have to change the sign between them to plus. Does that make sense? Now, we could leave the negative and just multiply by 4 and then subtract, and we'll get to the same spot. Does that make sense? Huh? Questions? Does that make sense? Yeah. Or I could call this matrix A, this matrix B, and do negative 3A minus 4B, and let the calculator figure it out for me. Does that make sense? We can either choose to apply the negative and the 4 and then combine what we get, or just apply the 4 and subtract. It's one or the other. Does that make sense? Because what I'm wanting to avoid is that you apply the negative like we did here, and then instead of adding, you go on and subtract again. We can't do that, because that's 2 subtractions. That's just going to change everything's sign. But if we did this here, the first thing we would apply is the scalar. And we could do negative 3 times 5, negative 3 times 0, negative 3 times negative 2, and negative 3 times 4. Well, negative 3 times 5 is negative 15. Negative 3 times negative 2 is 6. Negative 3 times 0 is 0. And negative 3 times 4 is negative 12. Now, negative 3 plus negative 1 is negative 15 plus negative 1, 0 plus 7, 6 plus 3, negative 12 plus 2 would give us negative 16, 7, 9, negative 10. I think we feel pretty comfortable with these here, yes? I could do more of these, but I don't think it's going to help you all understand them any better. I think the best thing to do at this point is to let you all try some on your own, or if you do have a question or a question does arise, I can answer it.